Good morning, everyone. I'm Jude, a software engineer on the Next.js team at Vercel. As we all know, AI agents can do a lot of stuff, right? They can read your code. They can even run your dev server for you. They can click around to the browser for you to do testing. But is there anything that the agents cannot do? Well, they can't see what Next.js knows at the framework level. They can't know what's happening at runtime. So they're blind to what's actually happening inside your app. So they don't see which routes are currently rendering on the page. They don't see why hydration failed. So all that rich dynamic context inside the core of the framework is invisible to them. Today, that changes, because for the first time, I'll show that AI can talk directly to the framework. You will see it in action: an agent fixing a hydration error, an agent editing the right file without much agentic search, and an agent migrating the entire app to Next.js 16. All powered by one simple idea: what if AI could see what the framework sees? So let's start with where we are today with dev tools. So developer experience has always been our North Star with Next.js. We've shipped clearer hydration errors, more readable call stacks, and also this completely redesigned UI for overlays. All of these tools are visually pleasing, they are interactive, they're built for humans staring at the screens, and they work to some extent. So when you see this error overlay, you instantly know what's broken. You can click through the stack and see the component. And because of the nice improvements we did for hydration error, you can also get the exact place of the hydration mismatch. This is great DX. But here's the shift. More and more of us are not staring at screens anymore. We're delegating to AI. So it all started with autocomplete. Then came this full AI-powered IDEs. And now some people just directly talk to terminal and see the features being built. So this work has changed. This workflow has changed fundamentally. Which means all these visual tools we've built, they don't work for agents. Well, you and I can see the error overlay clearly, but when you tell your AI to fix this error, it has no idea what you're talking about, because the AI cannot see what you are seeing for the overlay. So the critical context, the thing you need to fix the bug, is completely outside the agent's context window. It can read your source code, it can see your terminal output, but it can't see the Next.js internal states, which are so critical for the agent task at the time. So this creates a bizarre situation where you, the human, become the bottleneck. You have to manually copy-paste errors from your dev tools into the chat. So right now, you are the bridge between your tools and your AI. That's backwards. So let me show you exactly what this looks like in practice. This is what I call the context problem. So to make this whole idea more concrete, I have a demo prepared for you. So right here, I'm gonna zoom in here. So on the right side, you see on the dev tools overlay here, there is a hydration mismatch. And specifically, because of the nice improvement we did, you can see the exact mismatch, what's rendered on the server versus what's rendered on the client side. This information is so critical for AI to fix the error. But when you ask AI this simple question, right? Let me play it. can you see the runtime, the current runtime error, right? So out of the box, it just does a curl command over here, right? It tries its best because it doesn't have much context about Next.js. It doesn't know how to connect to dev tools to get this information. So it just does a curl. Right, you can see here it does the curl. So it doesn't have access to the browser. So of course, when you do the curl, you can't get the hydration error because the hydration error happens on the browser. It's not in the static HTML files. And then let me see what the final result from the AI is. So the AI responds, I don't see any runtime errors in the HTML output. The page appears to be rendering successfully with all the products displayed, etc. Right? So now you might think, right, just use Playwright, MCP, or whatever. So let the AI access the browser console, right? Done. Remember these hydration improvements I just talked about. They are different from what's in the console. Those specific improvements we did restricted to the overlay. So it's not the same if you just forward directly from the console to your AI. But the only solution right now is obviously you have to copy paste from that error overlay to the terminal. And as I mentioned, you become the API between the browser and AI. And that's certainly a bottleneck we need to eliminate. So obviously, we know that we had to fix this. And that I want to show you some of the earlier attempts that we made. So our first attempt was a new experimental flag on the screen called browser debug info in terminal. So the idea is pretty straightforward. So everything that's happening on the browser would likely be in the form of a console log. So if we simply forward the console log to your terminal shell, and your AI has access to your terminal shell, then it has access to whatever is on the console, right? That's the runtime information. So let me show you what that flow looks like, then I'll explain why we ended up building something much better. So on the right, you can see there's site can't be reached because the browser can't connect because the dev server isn't running yet. But I just mentioned something critical. If AI has access to a terminal, and then it can see the browser consoles after forwarding. So that's a restriction, which means when you start the AI agent, you have to run your dev server inside the agent. So in this case, I'm simulating it by just directly asking it to run the dev server. And it understands what I'm doing, and there's the pnpm dev. OK, and then you can see the page loads on the right. Let me zoom in. But the good thing here is it now actually reports back a mismatch between server and client render HTML in the headers element class name and structured in page.tsx. So the reason why it's now able to get that information is because this hydration error was a log in the browser console, and we forwarded that log to the terminal, and the agent here has some tool to scan the log of its own and to get this information. So that's how it works, right? But this works. Well, it solves the blindness problems, but it does come with trade-offs. So I'm going to talk about the trade-offs right now. Well, first, this only applies to logs. So there is certainly other kinds of information that's more important and hidden, implicit, inside Next.js core, but that's not exposed in the form of a log. Secondly, as we just saw, we have to explicitly start the agent first and then run the dev server. and then relies on the agent scanning of its own terminal. This is not how everybody codes. So for some of the synchronous AI flow, developers are still on the driver's seat of coding. And then when it sees an error, it will just point to Cloud Code and be like, can you fix this error? It's unnatural for me to stop whatever dev server I'm using and then switch to agent and start the dev server again inside from that point. And third, obviously, is the most critical, is AI has to scan every single file of the server output and can be very noisy. And it just burns the context window, and it's slow, it's inefficient. It's making AI worse at its job because it's drowning in irrelevant information. Well, then we asked ourselves, what if we could solve the same problem, giving AI access to the more context we have inside Next.js, but address all of these limitations? What if instead of making the AI scan logs, we can take a more proactive approach by asking direct questions? Well, today I'm excited to share that we are releasing Next DevTools MCP. This is our solution, and we think it's going to fundamentally change how you work with AI. By show of hands, how many of you know MCP? What is MCP? OK, for those of you who don't know, MCP is the open standard of agent to extract context from external sources created by Anthropic. But it's available to most of the coding agents. And now we're just applying that to Next.js. And specifically, we're allowing Next.js internal states to be transferred to AI agents via MCP. So for years, our dev tools have been a one-way conversation. They show us things like the error overlay, but you couldn't talk to the dev tools. And in this case, the MCP is that bridge we've been missing. So for the first time, your agent can simply ask the Next.js dev server direct questions. Are there any client-side errors right now? And the dev server responds with precise, structured, curated answers instantly. It's game-changing for bug fixes, code generation, and migrations. It's open source, and you can use it right now. So let's revisit that first example, but this time using MCP. So remember we had that initial limitation where we had to start the dev server inside the agent. But in this case, we're already running the dev server, which means it's outside the agent. As experimental feature before Next.js 16, you had to enable MCP servers in the nextconfig.ts. This step is no longer required because we've made this enabled by default since Next.js 16. And the second thing is you have to figure out how to connect MCP server to AI agents. Some people are afraid of this step, but it's not that complicated. So I just showed how you could do that with Cloud Code here. You do /MCP, and you check that it's connected to the MCP server. I'm using Cloud Code here just as an example. You can use it for any agent you want. And now let's continue. So we just typed the exact same question that we typed before. Can you see the runtime error, right? We see this error overlay down there, right? There's a hydration mismatch. Now we ask the exact same question. And now let's see how the behavior of AI agents change with MCP server enabled. OK, so the first step is the AI responds with I'll check for runtime errors in your Next.js application using the Next.js runtime MCP tool. So AI recognizes that this is a task that it needs to ask Next.js for help. And the first thing it does, it's doing discover servers so that you can make sure your AI agents can work with multiple Next.js instances at the same time. And the second, we discovered that the port of Next.js dev server is at 3000. And then we do MCP list tools on that port to see what tools are supported in that version of Next.js. And in this case, we got a list of tools. And then from the context of this problem, the get errors tool is the most relevant here. And Next.js now does the call tool for that tool, for the get errors. And then instantly, AI agents now can quickly verify that there is actually a hydration error happening on this right now, right, on this page. And it also has the full context of the nice optimizations that we've been doing to DX now to agents, right? Agents can quickly verify, okay, there's this, what's rendered on the server and what's rendered on the client and why they're different. So with this curated context, AI agents can quickly and reliably fix the hydration error from this point. They don't have to guess what might be happening that causes this hydration error. But I think most of us would be like, okay, I could have just copied and pasted the error right from the error overlay. What's the big deal about it? Like, can we do something more that we couldn't have done before? So let's talk about a next example where I will show something that's a bit more interesting than just forwarding whatever error state to agent. Let's talk about code generation now. It's the same app. Here's a more complex problem. I'll show you. So it's the same app. Suppose I already fixed the hydration error because AI gave that context. I fixed it. And now I'm going to show you one of the features I built here. So when you navigate to the product detail page on this grid by clicking this icon here, it shows up as a modal. But if you pay attention to the location, address bar here, it's products/1. So it's actually a real route change. It's not, a client-side modal. But if I refresh this page with the same URL, now I got a full page layout. Do you know what this feature is? Does anyone know what this feature is? Nice. Yeah, this is leveraging an advanced routing pattern called interception route that we built into Next.js. But you might be wondering, what does it have anything to do with MCP? Well, the difficulty part here is you have the same URL, but it could actually map to two different source files, right? These are two different source locations. If you navigate from the home page, you go to a modal source location, but if you land directly on that URL, you see the full page source location. They are two different source files. So even if AI could just take a screenshot with the URL and then do things with it, it's not going to work 100% of the time because it doesn't know which source file in your source code, in your code base is responsible for this view. Is it the full page route? Is it an intercepted route? Is there a middleware rewrite? Right? Is there a feature flag? Without framework-specific context, the AI has to guess. And usually, it guesses wrong. It might edit the full page one instead of the modal when you ask, can we change something on this modal? Because both share the same URL structure. This is where MCP really helps. Next.js knows its own routing. It knows exactly which file is rendering what. But we have to give AI access to that knowledge. So let's continue here. So let me try again. When I click this icon, you see there was like a bit of a delay. Let's suppose the problem right now is we want to address this delay here. So let me click again just to show you. Okay, click this icon. There was a bit of delay. So now I open this modal on the right, on the browser. So this is the context of the current state that we have a modal rendering. Now I want to change the current context state by adding a loading state. How could I do it? Well, I can do it just by saying add a loading state, and that's it. Because AI has access to Next.js internal now, and that context is implicitly provided to AI via MCP. Let's see it in action. So it first does a tool, maybe you didn't see that. It first does the get page metadata tool. And this one will give you what is the source file of the currently viewing web. So then the question about add a loading state without context would implicitly mean you want to do things onto this currently loaded page. And you can see here, it's even just directly reading from this intercepted route. This information would require a full code-based search and complex reasoning to understand it's actually this location, source location. Now it's just instant and it's upfront. And with that, AI successfully adds a loading state to it, and the page reloads, with the loading state. Isn't that cool? Okay, so that's code generation. The AI now can understand what's currently rendering and make surgical edits. But let's push this further. What about something way more complex, something that touches your entire code base? We just shipped Next.js 16. What if MCP could help with you migrate to Next.js 16? This is where it gets really interesting. Because MCP isn't just for answering questions, it's for orchestrating entire workflows. We can give AI a multi-step recipe like /upgrade Next.js 16 that combines MCP tools with official framework knowledge to handle massive, complex tasks. Let me show you what this looks like. So one command, Next.js 16 : upgrade Next.js 16 here. And this kicks off a full migration workflow, curated by the Next.js team. Huge shout out to my colleague Jachi for driving this effort. It doesn't just update packages, it walks through the full migration process, all orchestrated by AI, grounded in official Next.js migration guides, not just whatever it remembers from training. Well, does this work 100% of the time? Well, obviously no. Complex code bases have edge cases, although we've been testing it a lot on real-world applications. But when it hits something that it cannot handle, then just the human-in-the-loop step for the last 10%. So AI handles the mechanical work. You focus on interesting problems. That's what becomes possible when agents have deep framework access. So let me zoom out a little bit. So for years, we've focused on developer experience, DX, making you more productive. The dev server talks to you, and better errors, faster builds, clearer errors. But now we are adding agent experience, AX, making AI agents more productive. Next.js sits at the intersection of both. powered by the same framework knowledge, when your agent can query the framework directly, it stops guessing. It just works. That's what we are unlocking today. So this is still early, and we are evolving it quickly. I'd love to know what could make it truly useful for you, what kind of framework context would help. So we are building this together. If you scan the QR code, it will take you to the GitHub repo of the MCP server. Give it a try. Share your thoughts with me. Well, thank you.